Hello. Hello and welcome to this video. In this video, we will go through Datetime library of Python. It's quite big, so it will take probably 3 videos, maybe 4, I don't know, to fully complete this particular module. And we will see lots of examples as we go through. So it is quite useful module, Datetime, and you will use it quite a lot in your coding. So it is best that you understand this properly and be ready to make use of the facilities provided in your programming. So without further ado, let's get started. The datetime module supplies classes for manipulating dates and times. While date and time arithmetic is supported, the focus of the implementation is on efficient attribute extraction for output formatting and manipulation. So there are quite a few modules also other than datetime, that is calendar, time, and zone info. Then there are two external packages, for example, dateutil and datetype. Specifically, dateutil has expanded time zone and parsing support, and datetype package has distinct static types. For example, to allow static type tickets to differentiate between native and aware date times. Not native, naive. So first we consider what are aware and naive objects. Date and time objects may be categorized as aware or naive depending on whether or not they include time zone information. With sufficient knowledge of applicable algorithmic and political time adjustments such as zone and daylight saving time information, an aware object can locate itself relative to the other aware objects. An aware object represents a specific moment in time that is not open to interpretation. A naive object does not contain enough information to unambiguously locate itself relative to other date and time objects. Whether a naive object represents coordinated universal time (UTC), local time, or time in other time zone is purely up to the program. Just like it is up to the program whether a particular number represents meters, miles, or mass. Naive objects are easy to understand and to work with at the cost of ignoring some aspects of reality. For applications requiring aware objects, datetime and time objects have an optional time zone information attribute TZ_info that can be set to an instance of a subclass of the abstract TZ_info class. These TZ_info objects capture information about the offset from UTC time, the time zone name, and whether daylight saving time is in effect. Only one concrete TZ_info class, the time zone class, is supported by the datetime modules. The time zone class can represent simple time zones with fixed offsets from UTC, such as UTC itself or North American EST and EDT time zones. Supporting time zones at deeper levels of details is up to the application. The rules for time adjustment across the world are more political than rational, change frequently, and there is no standard suitable for every application aside from UTC. So the general idea is that when you will work on international application, most popular of them being the web application, where on the browser side you want to render date and time. For example, if it's a blog, you want to show when the post was made. Or a classic example would be Stack Overflow, where it shows when the object was or question was created or answer was posted. In that case, in database, typically you want to store the time with time zone. Naive times, that is time without time zone information, is not suitable for web applications. And we will encounter this later when we will do web application development. So let's proceed and we will see some examples after what we have. So the datetime module exports the following constants. Datetime.min year, the smallest year number allowed in a date or datetime object. Min year is 1. Datetime.max year. The largest year allowed in date or datetime object max year is 4999. Datetime.utc, alias for UTC, time zone singleton, datetime.timezone.utc. Now we have several available types in datetime. One is date, an idealized naive date, assuming the current Gregorian calendar always was and always will be in effect, and it has three attributes: year, month, and day. Datetime.time, an idealized time independent of any particular day, assuming that every day has exactly 24 multiplied by 60 multiplied by 60 seconds. There is no notion of leap seconds here. Attributes are hour, minute, second, microseconds, and TN info. Then we have datetime.datetime, which is a combination of date and time. And its attributes are the combined attributes of date and time. Then we have time delta, a duration expressing the difference between two date time or date extension to microsecond resolution. Then we have TN info, an abstract base class for time zone information. These are used by datetime and time class to provide a customizable notation of time adjustment. For example, to account for time zone and or daylight saving time. And finally, we have time zone, which implements the TJ info abstract base class as a switch offset from the UTC. Objects of these types are immutable, and we have following diagram. This is the inheritance diagram. From object you inherit date and date time. We have time delta, TJ info is abstract base class from which time zone is implemented. Now we have common properties. So date time, and time zone have following common features. These types are immutable and hashable. In general, when objects are immutable, they are almost always hashable. And that means that they can be used as dictionary keys. These objects of these types support efficient pickling via the pickle module, which we will see later pickling. When we were talking about struct, I talked about pickle, and we will see it when it comes in the order. Determining if an object is aware or naive. Objects of date type are always naive. An object of type time or date time may be aware or naive. A date time object D is aware if both of the following hold. D.tz info is not none. D.tz info UTC offset D does not return none. Otherwise, D is naive. A time object T is aware if both of the following hold. T.tz info is not none. T.tz info.UTC offset none does not return none. Otherwise, T is naive. So this you should keep in mind. Okay, that when the time and date time objects are naive or not, and date is always naive. Okay, the distinction between aware and naive does not apply to time delta object. You will see what is time delta now. A time delta object represents a duration, the difference between two date time or date instances. Note that it doesn't differentiate between two time objects. It differentiates between date time and date instances. So we have the time delta constructor. So it takes the expected arguments, days, seconds, milliseconds, microseconds, minutes, hours, and week. So these are by default all are taken as zero value. All arguments are optional and default to 0. Arguments may be integer or float and may be positive or negative. Note that time delta is not immutable. It is a mutable type. Only days, seconds, and microseconds are stored internally. That is another distinction to be understood. Only days, seconds, and microseconds are stored internally. I repeat it. So milliseconds, minutes, hours, weeks are not stored. Arguments are converted to those units. A millisecond is converted to 1000 microseconds. A minute is converted to 60 seconds. An hour is converted to 3600 seconds. A week is converted to 7 days. And days, seconds, and microseconds are then normalized so that the representation is unique with microseconds are between 0 to 1 million. And seconds are converted between 0 to 86,400. That is 3,600 multiplied by 24. And days are between these ranges. Let me read those. Unit 10, 100, 1000, 10,000, 100,000, million, 10 million, 100 million. So 999 million, 999,999 days. The following example illustrates how many arguments beside days, seconds, and microseconds are merged and normalized into these resulting attributes. So we import datetime as dt and we create a time delta object. Days is 50, seconds is 27, microseconds is 10, milliseconds is 29,000, minutes is 5, hours is 8, and weeks is 2. But if you want to look at the string representation, if you just want to see what the object is, then it's called 64 days, 29,156 seconds, and 10 microseconds. Import datetime as dt instead of import datetime or from datetime import datetime is to avoid confusion between the module and the class. Because the module name is also datetime and the class name is also datetime. Okay, so it is best that you use datetime as dt. If any argument is a float or there are fractional microseconds, the fractional microseconds are left over from all arguments are combined and their sum is rounded to the nearest microsecond using round half to even tiebreaker. If no argument is a float, the conversion and normalization processes are checked, no information is logged. If the normalized values of days lie outside the indicated range, overflow error is raised. So number of days should be less than 10 million. Number of normalization of negative values may be surprising at first. For example, if you construct it with microseconds is equal to -1, then remember it has to be converted to days, seconds, and microseconds. So what happens here is days become -1, and then you add 86,399 seconds and 999,999 milliseconds to get -1 microsecond. Since the string representation of time delta object can be confusing, use the following recipe to produce a more readable format. So a pretty time delta function is written which accepts a time delta object. And if days are greater than or equal to 0, then it represents the string format of time delta object. Otherwise, it is a what is called format string, and it puts a minus sign before that. So time delta hours is equal to -1, and if you want to say pretty time delta, it prints the time delta object with a negative sign. So this is something you can do if you want, or otherwise you can rely on this. Okay, just remember that whatever value you put, it will be converted to days, seconds, and microseconds. Then we have time delta dot min, which is the most negative time delta object, which will be time delta minus the number of days, maximum number of minimum days. That is 999,999,999. And then we have max, which is the positive side of that, plus 23 hours, 59 minutes, 59 seconds, and 999,999 microseconds. The resolution is the smallest possible difference between non-equal time delta object, that is microseconds is equal to 1. So for example, let me show you something here. We do Python and we say import datetime.dt as dt. Okay, and then we can say that dt dot time delta dot resolution. In there we have microseconds is equal to 1. Okay. Note that because of normalization, time delta dot max is greater than minus time delta dot min minus time delta dot max is not representable as a time delta object. Okay. So this you cannot represent as a time delta object. Instance attributes read only. Time delta dot days, seconds and microseconds. Because internally it stores only these three attributes. So objects will have only these three attributes. So let's see this. For example, if you want to run this, let me show you okay, exactly. There is no point, but duration is there, then you can pick up duration in seconds. There will be no microseconds, of course. So these attributes, days, seconds, and microseconds are read only. You cannot write to them. And then we have total seconds object also. So we can say that duration dot total seconds, and we get total seconds also. So it's a function which you can use that. Now we have some supported operations, so you can add two time delta objects. So for example, let's say td1 is equal to time dt dot time delta. Let's say this is equal to 1, right? For simplicity, and we say td2 days is equal to, let it be also 1, okay? And then we can say that td3 is equal to td1 plus td2. And then we say td3 dot days. So since we added the time delta, now days are 2. Similarly, you can subtract td3 is equal to td1 minus td2. And then we say td3, so it is 0. Similarly, you can multiply this, so td1 multiplied by say 2, and then we say td3. So let's take a complex, slightly complex object, dt dot time delta. Let's make it days is equal to 1 and seconds is equal to 30 and microseconds. Let's make it 5,000. Okay. Oops. This should be dot. And then we say td3 is equal to td1 dot td2 multiplied by 2. Okay. And then if we see td3, so see, it was doubled. Microseconds was doubled and it exceeded the 1 million. So 1 second was added, 30 into 60 plus 1, days have become 2. So similarly, you can try all these operations. You have multiplication, then you have multiplication by float. You can divide two durations of time, two objects of time delta. You can divide with float and integers. You can do compute the remainder. Okay. You can do this mod, which will give you the quotient and remainder. You can return a time delta object with the same value. You can negate it. Okay. Remember, negation is this. Okay. Days, seconds, and microseconds are negated. Equivalent to multiplying it with -1. You can take absolute values equivalent to plus t when t dot days greater than 0 and to minus t when t dot days less than 0. You can return a string in the form of this. Okay, so for example, we can say str td3, and there we go. And then we have a returns a string representation of the time delta object as a constructor call with canonical values. Notes. This is 1. So 1 was this one when you multiply. Okay. This is exact but may overflow. 2. 2 is which one? 2 is this one plus t1. Okay. This is exact and cannot overflow. Division by 0 will raise 0 division error. Minus time delta dot max is not representable as a time delta object. String representations of time delta objects are normalized similarly to their internal representation. This leads to somewhat unusual results for negative time deltas. For example, time delta, when you put minus 5 hours, it becomes minus 1 days and 68,400. So how this became is that if you look at 1 day number of seconds is, that is 24 multiplied by 3600, that is 86,400 seconds. And 5 hours is 18,000 seconds. So you subtract, you get 68,400 seconds and minus 1. So if you add 68,400 seconds to minus 1, you get 18,000 seconds negative. So that is what is mass 5. But if you print underscore, that is the string representation, gives you this. The expression T2 minus T3 will always be equal to the expression T2 plus minus T3, except when T3 is equal to time delta dot max. In that case, the former will produce a result with the latter will overflow. In addition to the operations listed above, time delta object supports certain addition and subtraction with date and date time objects. Float division and true division of time delta object by another time delta object are now supported, as are remainder operations described in version 3.2. Time delta objects support equality and order comparisons. In Boolean construct, a time delta object is considered to be true if and only if it isn't equal to time delta 0. And total seconds, as I said, it is an instance method. It returns total number of seconds contained in duration. Okay. For very large intervals greater than 270 years or more, most platforms, this method will lose microseconds accuracy. More examples are given. So normalization example is here. We have a year, TD.time delta 365 days. Another year we take as 40 weeks, 84 days, 23 hours, 50 minutes, 600 seconds. And it checks whether year is equal to another year. So if you look at this, 40 weeks is how many days you have got. Okay. 40 weeks is 280 days. 280 plus 84, 364. And then 600 seconds is 10 minutes. 10 and 50, 60 minutes. 60 minutes is 1 hour. 1 plus 23, 24. That is 1 day. So total 365 days is also there. So that's why year will be equal to another year. Then we have, we create a time delta year object with 365 days and multiply 10. So we now have 3,650 days. The number of days in this will be 3650, it should be, right? Why it shows 10? No. This seems like something wrong. 10 years not days will have 3650. 9 years would be 10 years minus year, that is 9 years, would have 3,285 days. 3 years is equal to 9 years, and 3 years comma 3 years dot days, that will be equal to 1095 comma 3. So you have to divide by 3 actually here. Okay. Okay, so this is not a comment, okay? It is because of the color I got confused. You are doing a div mode operation here as well. Okay. Then we have date and date objects. The date object represents the date, the year, month, and day in an idealized calendar and current Gregorian calendar, indefinitely extended in both directions. January 1 of year 1 is called day 1, January 2 of year 1 is called day number 2, and so on. So the constructor takes year, month, and day. All arguments are required. Arguments must be integer in the following ranges. Min year should lie between min year and max year. Month should be between 1 and 12. And day equal to number of between 1 and number of days in the given month and year. If an argument outside those ranges is given, value or is saved. Other constructors are also there, which are all pass methods. One is today, this is not a constructor, it returns the local date and is equivalent to date dot from timestamp time dot time. Date dot from timestamp, it takes timestamp, return the local date according to the POSIX timestamp, such as returned by time dot time. This may raise overflow error if the timestamp is out of the range value supported by the platform C local time function, and OS error if local times on local time failure. It is common for this to be restricted to years from 1970 through 2038. Note that on non-POSIX systems that includes leap seconds in their notion of a timestamp. Leap seconds are ignored by from timestamp. Then we have date dot from ordinal, where it takes an ordinal, return the date corresponding to the proleptic Gregorian ordinal, where January 1 of year 1 has ordinal 1. Value error is raised unless 1 less than equal to ordinal less than equal to date dot match dot to ordinal. For any date D, date dot from ordinal, D dot ordinal is equal to D. Then we have from ISO format, return a date corresponding to date string given in valid ISO 8601 format with the following exception. Reduced precision dates are not currently supported, that is YYYYY minus NM or YYYY. Extended date representation are not currently supported, that is plus minus 6 digits in years. Ordinal dates are not currently supported, YYY minus 4. So how we can create from date time ISO format is you give YYYY minus DD minus MM and we create the object. So there are 3 examples which are given here. This is week 01. So you can look at the specification of ISO 8601. The most common format ISO format is this one, where there is no delimiter and you give it as YYYYMMDD. Then we have date from ISO calendar. Return a date corresponding to the ISO calendar date specified by year, week, and day. This is the inverse of the function date.ISO calendar. Then we have strp time. Return a date corresponding to a date string according to format. This is equivalent to date star time.strp time date string format 0:3. Value error is raised if the date string and format can pass by time.strp time or if it returns a value which isn't a time tuple. See also strst time and strp time behavior and date from ISO format. If format specifies a day of month without a year, a deprecation warning is emitted. This is to avoid a quadrennial leap year bug in code seeking to pass only a month and day as the default year used in absence of one of the format is not a leap year. Such formal values may raise an error as of Python 3.15. The workaround is to always include a year in your format. If parsing date string values that do not have an year, explicitly add a year that is a leap year before parsing. For example, if our date string is 02/29, when we are parsing it, we add the year 1984. So this is an example which avoids leap year bug. Okay, so be careful when you are using strp time that we need to supply year, date, and month appropriately. Then we have several class attributes. Date.min, which is min year, 1, matches, max year, 12, 31. Resolution is days is equal to 1, time delta day is equal to 1. And then we have read-only attributes, year, month, and day. And the operations which are supported are, you can add time delta objects to date and subtract. You can subtract 2 date objects to get a time delta. You can check for equality using is equal to and not is equal to, and you can also check compare two objects using less than, greater than, less than is equal to, less greater than is equal to. So these operations are all supported on date objects. It's quite big. I think we can stop here. Let me show you some examples of date. pt. So which one should we use? from ISS format is what we will take. Date dot ISS format. And we put today's date. So this is 05 May and today is 19th. Okay. Okay. It should be and we put let's say tomorrow's date. So we have another one. And then we can say that sorry, I have assigned to variable. So we say day one equal to this and day two is equal to this. And then we can say day one minus day two. And you get time delta. And we can check whether it is less than or not, which is true, less than is equal to or not. We can similarly check whether both are equal. So these are some examples you can use. And from in the next video, we will start from here, okay, where we are starting. It is quite big, so it may take 3-4 days. Let's see how big it is. There are quite a few examples are also there. Yeah, it should take 3 days with examples and all. So 2 more videos for this, and we should be able to cover. So I hope that you have found this video useful, and it is certainly useful because later on you will need to use these when we are writing code. So I thank you for watching the video, and I'll see you in the next one, 4th day from us. And make sure that you practice different things, and some of the things you may need to keep in mind. For example, the strp time stuff, which we talked about, and the fact that TimeDelta.max cannot be represented as an object and all that. So the specifics which we have covered, yeah, do remember those. And with practice, you will remember. It's not that you have to just mug it up. With practice, you will remember. So practice with this, and I'll see you in the next one. Till then, sayonara.